Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. The fall semester is finally over and I'm celebrating my students' successful completion with a video that I hope you'll find fun. I was wondering if I could use a microbit to control a pygame game. After some searching on the internet, I found that somebody has written a library so we can do just that. This is Kasper's microbit, and this is the library we're going to use. More on that in a moment. First, you might be wondering what a microbit is. A microbit is a really cool little microcontroller, or microcontroller plus hardware, to make it easy for us to interface with the microcontroller. They were originally created by the BBC's Make It Digital initiative and were distributed to Year 7 students in the UK to inspire young people to become digital pioneers. I'll include a link to the BBC Microbit website in the description. Microbits are interesting in part because they have buttons and an accelerometer, a device that measures changes in speed and direction, which is a cool sort of input to collect and use to control a game. Plus, your game can communicate with a microbit over Bluetooth. Now, I haven't written anything groundbreaking here. I've just swapped keyboard control for accelerometer and button control on a few small programs I already wrote, just to see how it works. And I'm going to show you one example so you can take this knowledge and build something great. Let's return to the Kasper's microbit library. I was reading this Stack Overflow page on how to use serial ports over Bluetooth with microbit, and at the bottom there's an answer to the question. I created Kasper's microbit to make it easier to connect to the BLE services of a microbit using Python, from Janick R. I'm so grateful to Janick Reynders for creating this library, and apologies if I'm not pronouncing Janick's name correctly. Here's the Kasper's microbit website. The code is licensed under the Mozilla Public License version 2.0. There are a number of examples here, which I drew heavily from. So let's look at the process for using this in a pygame game. The first thing you'll need to do is install the library. So at the command line, you'll type pip install Kasper's microbit. I already did this and didn't record that step, but it's probably the same way you installed pygame, just substitute Kasper's microbit for pygame. Once you've done that, you can see the installed files by going into your Python installation, and then into lib, then site packages, and then Kasper's microbit. You'll also want to prep your microbit, so connect it to your machine and copy the hex file from the Getting Started page on the Kasper's microbit website to your microbit. You can just drag that right over to the microbit. And now for the fun part. Let's take a look at a little platform program that has a penguin moving in a little ice castle. I'm going to disconnect the microbit from the computer and plug in a battery pack, just to illustrate that we're communicating via Bluetooth. And I'll record my hands as well as the screen and run the program. You can see that the penguin moves right if I tip the microbit to the right, and it moves left if I tip to the left. And it jumps if I press the A button. Let's look at the code. At the top, I have some import statements. I have from Kasper's microbit, import Kasper's microbit. From Kasper's microbit.services.accelerometer, import accelerometer data. From Kasper's microbit.services.buttons, import button state. Kasper's microbit is the class we use to connect to our microbit. Objects of the accelerometer data and button state classes hold exactly that information, accelerometer data, and button state. I'd say very similar to the device classes built into pygame, such as mouse and joystick. To start, in main, we set up all of our assets as usual. But then we find the microbit, and the game loop is embedded within this with block, with Kasper's microbit.findOneMicrobit as microbit. When I ran the program, you may have noticed it took a little bit of time to start up, and that was the program finding the microbit. Now here's the overview first, and then we'll go into more detail. Before our game loop, we're setting up callback functions for when there are changes in the microbit sensors that we're interested in. In this program, I'm interested in the accelerometer and button A. Those callback functions create pygame events corresponding to changes in the microbit state. In the game loop, in the event loop, we're then processing the new pygame microbit-related events in the regular event processing, along with any other events we want to process, such as a quit event. I've actually left all of the original keyboard event processing in here, but you'd probably want one or the other. That's the overview. Set up callback functions that will create pygame events when something happens with the microbit accelerometer or button A, then process those events in the event loop. Now let's look at all of that in a little more detail. In our program, we write with Kasper's microbit.findOneMicrobit as microbit. So whatever is returned from Kasper's microbit.findOneMicrobit is what we're going to refer to with the name microbit in our code within the with block. Our entire game loop is in the with block. Let's take a look at what findOneMicrobit returns. This is in the Kasper's microbit.py file. If we scroll to the bottom of the method, we can see it returns an object of type Kasper's microbit, as long as it finds one. If we look at the initializer of the class, we can see it has fields device information, generic access, buttons, temperature, accelerometer, etc. So, microbit.accelerometer will refer to a wrapper class that gives us access to the accelerometer data of the microbit that was found in the findOneMicrobit call in the with statement. And microbit.buttons will refer to a wrapper class that gives us access to the button data of the microbit that was found in the findOneMicrobit call in the with statement. These are wrapper classes within the Kasper's microbit code, and what they will allow us to do is set up a callback function that they will call when there are changes in their respective input devices. In some places, I just want to note, I've asked Google to translate the comments for me from Dutch to English. So when we look at the Kasper's microbit code, you might see some English comments that are Google translations. Okay, so if we look at accelerometer service, we can see a method called notify that takes a callback function as a parameter. And if we look at button service, we can see on button A and on button B, and these take named parameters that are callback functions for different states of the button: press, long press, and release. So we can define different callback functions for each of those state changes. What we're going to do is install callback functions that create a pygame event when there are changes in the state of the microbit sensors we're interested in. So we write functions that create special events, and we pass them to the notify and on button A methods, and our functions will be called when something happens. There's a small difference in how we pass the functions to the notify and on button A methods. Remember that the on button A method takes three named parameters: press, long press, and release. We could write separate callback functions for the different states of the button, but I'm interested in press only, so I'm passing in press equals and then the name of the callback function. Note that when we're passing a function as an argument, we do not put parentheses after the function name, because we're passing the function as data. We don't want to call it, we want to pass it so it can be called at a later time. Let's look at those callback functions in more detail. So here, when we write microbit.accelerometer.notify post accelerometer event, and when we write microbit.buttons.onButtonA press equals post button A press event, we're connecting the callback functions to the object wrapped around the microbit. We need to write those callback functions so they'll create an event and post it to the event queue so we can pull it off the queue and process it in a synchronized way in our game loop. Now in Pygame, you can create user-defined events. Here is the Pygame event documentation. Here is the list of predefined events, which you are already familiar with, such as key down and mouse button up, for example. If we want to create our own event, we can invoke pygame.event.customType, and it will return a unique integer, which will be our event's constant. We want to use this so that we don't have a collision with a current or future event constant. So I'm creating the event constants at the top of the program with the other constants by invoking pygame.event.customType. I am creating two event constants for two event types, accel event for an accelerometer event, and button A pressed for an event if the A button is pressed. Now after all of the sprite code, I then have two functions, one for each type of event, and the functions are the callback functions that will be passed to the notify method of the accelerometer service object and the onButtonA method of the button service object. These functions create and post events. Now think about an event when we're processing it. It first of all has that constant, which is how we know what kind of event has happened, so we know how to process it. That's in the type field. So we write if e.type equals pygame.quit or mouse button down or key up or whatever kind of event we want to handle. And then it has a dictionary of additional information depending on the event type. If it's a key up, it's going to have information about what key was pressed and what modifier keys were pressed, whereas if it's a mouse event, it's going to have information about the mouse's location and what buttons are pressed. Now in our callback function, we're creating the event dictionary and it can contain whatever we need. My first callback method is called post_accelerometer_event, and it takes an argument which is of type accelerometer data. This is defined in the Kasper's microbit accelerometer file, and you can see it has values X, Y, and Z. I at first thought I would use both X and Y in this game, and I've left that in here, and that's okay. You might want X, Y, and Z. I really only want X. So I'm creating a dictionary with an X key and the data.X value, and a Y key and the data.Y value. And then I'm creating an event by invoking the event constructor, pygame.event.event, and I'm passing in the type. This is my accel event type and the dictionary. And then we're posting that event with pygame.event.post. And below this, I have another callback, this one for the button A press, called post button A press event. And I don't need a dictionary for this one, because I'm just going to make the penguin jump if the user presses the A button, and I don't need any additional information except that the event happened. So I'm again constructing an event, this time with the type button A pressed, and that's all I'm passing into the constructor, and then I'm posting that event. Okay, and then down in the event loop, you can see I'm handling both kinds of events by sending messages to my penguin sprite. I'm not going to go into details about how this little program works. This is from my book, and this modified code will be in my GitHub repo with a link in the description, so you can dig into it all you like there. If there's an accelerometer event, I look for which way the microbit is tipped. and send the penguin a process move command message with either left or right as an argument. And if the A button is pressed, I send him a process move command with up as an argument. And as I mentioned, I left all of the original keyboard processing in as well. Okay, we've looked at how to construct this, but let's talk about dynamically what is happening. So dynamically, we run the program, and after a little bit of asset setup, we look for the microbit, and once found, we immediately hook up callback functions. So as soon as we find the microbit, we tell it if there's an accelerometer change to call the post accelerometer event function, and if there's a button A press to call the post button A press event function. Now the program starts running. If anything happens with the accelerometer, our post accelerometer event function is called, and that puts an event on the event queue of type accel event with the data about the position of the microbit. And so 30 times a second, we're pulling events off the event queue. We'll very quickly pull that event and handle it by telling our penguin to move left or right. And if the user pushes the button, the Kasper's microbit code will be calling the post button A press event function, and that will put a button A pressed event on the event queue. And again, we'll be pulling those off the queue 30 times a second, so we'll tell our penguin to move up. Finally, you might notice I'd written a print accelerometer data function, and I had initially installed that as the callback function to the accelerometer. That's because I wanted to get a sense of what the X and Y values were for different motions, so I could tip the microbit back and forth and see what values were printed. Once I had a sense of the values to expect, I could write my event handling code. There is a nice detailed comment here in the accelerometer service class, but I do like to experiment with game inputs because it helps me get a feeling for them. Okay, isn't this so cool? I'm so grateful to the author, Janick Reynders, for creating this library. I hope to play around with it more, but I may not get a chance soon. I hope that you're able to build something really cool with this. Have fun.